and gentlemen, this is Waves of the Electromagnetic Spectrum and correlates to Chapter 16.2 in your textbook. Your key concepts and vocabulary for this video are: what is the difference between an electromagnetic wave and an electromagnetic radiation? How do electromagnetic waves compare? And what makes up the electromagnetic spectrum? So what is the difference between electromagnetic waves and radiation? An electromagnetic wave is a transverse wave. It's made up of electric and magnetic fields. Now, what this looks like is here you've got that magnetic field going side to side, and an electric field going perpendicular up and down, but they're both transverse waves and they travel together to make up those electromagnetic waves. And when they're traveling through space where there's no matter, or mediums where there is matter, at the speed of light. So that's pretty fast. Now, when we say electromagnetic radiation, we're talking about the energy transferred on those electromagnetic waves. So let's look a little bit more about these waves. How do they compare to each other? Something that's the same between all electromagnetic waves is their speed. Now, when they're in a vacuum, meaning like space where there's no matter, they travel at the speed of light, all of them. Radio waves, microwaves, infrared radiation, gamma rays, X-rays, all the speed of light. Now, what's different between all of those ones that I just rattled off is their wavelength and their frequency. And we're going to look at that a bit more as we look more into what makes up our electromagnetic spectrum. So here we have radio waves, microwave, infrared radiation, visible light, ultraviolet, X-rays, and gamma rays. Let's start off looking at our electromagnetic spectrum in the middle. Visible light. It's a very small portion. I read somewhere that if the electromagnetic spectrum was stretched from Sacramento or San Francisco, California, up to Seattle, Washington, the visible light portion of the electromagnetic spectrum would only be an inch wide. That's tiny. But within this little tiny portion makes up everything that we see. All the colors we see, every experience we have is made up from this tiny portion of the electromagnetic spectrum. And it has medium wavelengths, medium frequency, and medium energy. And one cool thing about it is I told you all the colors we see come from this electromagnetic spectrum. Here in the visible light, you look at the red, it's got a longer wavelength than the violet. It has a lower frequency, violet has a higher frequency. These different frequencies make up the different colors. And yes, remember Roy G. Bibb from elementary school? That order of red, orange, yellow, green, blue, indigo, and violet still applies because that's the order we have it in the visible light spectrum. So let's go to the end of the electromagnetic spectrum, at radio waves. Now, radio waves have the longest wavelength, the lowest frequency, and the lowest energy of every wave in the electromagnetic spectrum. And when you think of a radio, yes, those use radio waves. When we say longest wavelength, I want to emphasize how long it is. We're talking several soccer fields or the distance between mountain tops. Radio waves are ridiculously long. They're huge. So don't just think, oh, long like a mile. No, it can be several miles long. So a little bit shorter in their wavelengths are microwaves. So they have a longer wavelength than visible light, but shorter than radio waves. They have a lower frequency and a lower energy. And when you think of microwaves, you probably think of your microwave oven, but you should also think of your cell phone, you should think of Wi-Fi, and you should also think of radar guns that you use to clock speed. So if you ever get pulled over for a speeding ticket once you start driving, don't speed. But if you do, this is how they would have determined your speed. Or if you watch baseball and you see the speed of the pitches or the hits, this is how they figured out with a radar gun measuring microwaves. Now, infrared, if you remember back to our energy unit, we feel infrared radiation as heat. Infrared has relatively long wavelengths compared to visible light, low frequency, and low energy, and it makes up a good portion of the electromagnetic spectrum. And we can measure and see this infrared radiation with a thermogram. So even though our eyes can't see it, we have designed machines to be able to see it. The brighter redder colors show hotter temperatures, and the cooler blue colors show cooler temperatures. We're back to visible light. Now, here's a trick for those of you that are having trouble remembering the order. So where does the red go? So remember, infrared leads into the red side of the visible light spectrum. And ultraviolet leads in, well, comes from the violet end of the visible light spectrum. So as long as you can remember infrared, Roy G. Bibb, and ultraviolet, you'll know which order it goes in. So let's look at ultraviolet. Ultraviolet is one of the dangerous ones because it has relatively high energy with a high frequency and a short wavelength. So it can be quite dangerous and cause things like skin cancer. However, it also can be very good because without the ultraviolet light, our bodies would not be able to create vitamin D, which our bodies actually need to have healthy, strong bones and a lot of other processes in our body. So some ultraviolet's good, a lot bad. Another thing that's dangerous for us are X-rays, but we find them very useful. These have a shorter wavelength, a higher frequency, and a higher energy. And this higher energy lets them penetrate through our tissues so we can get X-rays and see broken bones. Or we use it in customs to be able to X-ray objects without opening them to see if there's anything dangerous inside of them. But they are very dangerous, especially to our tissues, which is why you might see these signs saying, if you're pregnant or possibly pregnant, please tell us before you have an X-ray, because if you are, they might not be able to do that X-ray depending on where it's going to be on your body so they don't hurt the baby. Now, last but not least, we've got our gamma rays. Now these ones are the shortest wavelengths. They have the highest frequency and the highest energy. The only time you have these gamma rays here on Earth is when we use them for a very special procedure it's like an X-ray but more intense. Otherwise, we use them for astronomy a lot because stars produce them. We also will use them for cancer treatments. So medical X-rays that X-rays can't do, or cancer treatments, and star releases. That's it. Be sure you notes hit all the key concepts and vocabulary.